power source with them.
It's floating around us. Fun fact is that 30 years ago, Telstra was the biggest user of solar panels in the world. 2.4 metre cube containers were basically satellite earth stations you could drop in at a station or a phone box and get ISDN. It was a project 30 years ago. 10-year-old batteries, and generally a battery rate to like 80% capacity. And, the reality is the predictions of them lasting 6,000 cycles and things may even be conservative.
Really? Just been sitting down with David Minchin. What an absolute legend. He's an engineer's engineer. What he doesn't know about renewable energy, especially battery storage, it's not worth knowing. I learnt so much from this conversation. He's insightful. He has wit. It's the complete package, complete and utter joy. So without further ado, sit yourself down, strap yourself in, and let's get stuck into it. You're Australian born, I assume.
Yeah. So I was actually born in Adelaide, but grew up on a farm north of Adelaide. I've been in the family more than 100 years these days. So one of 5 kids, was the eldest, and it was very early in the piece that both mother and father said that none of you kids are going to stay on the farm. We want you to be educated, see the way, travel, follow your strengths.
But that's not, in a lot of cases with farming families, they'd like someone to inherit the farm. Is that, why?
It's an interesting thing because, without going into too much detail, we still have a lot to do with it, but then we manage it and we use external labour and have done for nearly 40 years, and that's worked out well. And it's not livestock, it's wheat and barley, and that's sort of following the global trends of change of environment and things like that. It's close to the Barossa Valley, but no underground water. And no one's got to plant grapevines these days, but it's still very successful in malting barley for beer and wheat for bread, basically.
So you grew up in a farm situation, but your parents earlier on said, "Nah, kids, get out of here, go and see the world."
Yeah. So the kids, we've all taken different paths. I sort of went. My father is my influence as far as electronics go, and he was a qualified technician back in the day. They didn't call them technicians. But then one of my other brothers works for a very large multinational wine company as a vintner. My sister ended up running the Australian Water Quality Laboratory, so water scientist. And my youngest brother, who unfortunately passed a couple of years ago, became a police sergeant.
Wow.
So all went in different directions.
You growing up, obviously you're in the country, so you did all those things that boys do, shooting, fishing, riding your bike, mucking around.
Yeah.
That's changed a lot now, hasn't it? Like, as in just, that whole thing of how kids are being brought up.
Yeah. It's something, as there's what I call, you appreciate risks better when you get older. But it was interesting. So it always had an analytical approach, and it was something my siblings shared as well in different areas. So yes, we go along the back road in an old car at very high speeds and things like that, but it was safe, and we sort of learnt by experience, but we had a lot of props around us. It was a father and dad still alive, 95.
Wow.
Still into technology and things like that. It was encouraged. Mum, she passed quite a few years ago, but she was into aviation, and her brother was at the end of World War II was a pilot. And Mum sort of went through the whole experience. She trained as a nurse, but she actually went from nursing to running the Meyerberg Street front window here in the 50s, things like that.
Wow, which is still going strong.
Yeah, she did the decorations, and she was very organised. She was the manager, I suspect. Dad was the technical expert, but we would bounce from electronics to model aircraft, which was a thing, I think, not so much these days, but it was a thing back then that you sort of hands-on. It was very much hands-on, but with some, Dad would always do a risk assessment. Never crashed a model aircraft. because he always did a risk assessment.
So would it be fair to say that both your parents were like process and procedure driven kind of people?
Yeah, absolutely. Yeah, and that was the education side of it. We were on a farm, but early 70s, transitioning from what technically sort of probably a middle-sized farm. Clearly economic pressure around the 70s. There wasn't as much money. It was still profitable, but we couldn't all be sent to private schools and things like that. So chase scholarships, things like that. And
so it wasn't a case of distance learning because you weren't that regional.
No, only within an hour of Adelaide.
Oh, okay.
Yeah, close. So it's but it was we were really helped to chase our dreams. And that's interesting when you're 12 or 13 trying to think of what you've got to do. I was going to go thinking I could fly, be in the RAF because we're very close to Edinburgh and RG research. We'd be out and get buzzed by the Mirage or the Mackies flying around doing whatever they do.
Aircraft is pretty impressive. We're on a flight path for training by we don't know who, but it's not the police. I think it's some kind of army thing up in the Dandenong Ranges.
Right. Yeah.
Definite flight path because some of those helicopters, and I don't know helicopters, but some of them they're pretty big and they have this. Yeah, they're not your standard helicopter. I don't think. As a child, did you? And I asked this of all engineers.
Right.
Did you get stuff and you want to know how it worked and you pulled it apart and tried to put it back together again and sometimes it worked?
Absolutely.
Every engineer I ask,
yeah,
they all have done that. Every single one.
Yeah, I think there's a Dilbert cartoon that sums up engineers, and it's like a 5-year-old kid, and it's in the waiting room, and the mother is there with the doctor, and the doctor's going, "I'm sorry, I got some bad news. Your son's going to be an engineer." and meantime, the kid's reassembled a photocopier or something else, that sort of thing. But curiosity,
yes.
And it's engineers care about things a lot of other people don't, and it's one of those things that natural curiosity, I think,
and problem solving.
Yeah, and that's the importance of STEM these days because it's sort of the revitalisation. I train young engineers that come into the organisation, and that hunger's still there. And parenting's got a lot to do with it, but the opportunities to play with things, and there's still plenty of things to play with. It's not you're not playing so much with transistors now. You're playing with something which is it might be software or hardware or both, that sort of thing. But it's, to me, if that was around back then, that would have been what I played with.
Did you have a crystal radio set?
Yeah,
right.
Age 7.
Yeah, wow. yeah. I had a friend who had one, and I still just couldn't understand how the thing worked. And I still sort of don't understand how they work.
Yeah.
Because where's the power source with them?
It's floating around us. Electromagnetic radiation. And in basic terms, you have a junction which is directional, and all it needs is 0.3 or 0.6 of a volt for it to conduct, and it then you can produce audio. So it's when you think about that, if working in an MC environment, you go, okay, it's all around us. Yes, there is radiation around us of the level. The way the voltage is amplified is that you use a long wire that captures, and especially say for AM where the wavelength is several hundred metres, the capture area is what does the actual amplification. So you end up with
amplitude
modulation,
as opposed to frequency modulation with FM.
Yeah, frequency modulation, totally different, but in the end it's another form of modulation. But crystal set will resolve, and it detects the change in amplitude, and that is at an audio rate. You then need a very high impedance, in other words, low current set of headphones, and that's your crystal set. And there's still AM radio stations everywhere. You could hook up a wire out in your back road or backyard, whatever, and you just have to find yourself a pair of old-fashioned headphones.
Why don't they? I mean, you know how they talk about emergency services, and they talk about having a wind-up radio in the kitchen and bushfire. Why couldn't they use a crystal radio set?
It's the limitation. It relies on a very high power transmitter. So
a very high what?
A very high power transmitter. So the transmitter at the other end has a large antenna minimum of 2,000 watts of RF radiation.
Right.
ABC run 50,000 watts, so it's it's very unbalanced.
Yeah. I see.
It's an interesting thing, and it's probably the old days. Now you would buy a Schottky diet. The old days it was a bit of gallium and a cat's whisker.
Yeah, I've heard that term.
And you find the little gold cat whisker. You find the sensitive spot on the bit of gallium, and hopefully nobody walks past and bumps it, and you lose the. So I didn't go down that road. It was more modern, but it was a phase. But then you soon found that for another $2, I'd hop on the train, go to Adelaide, go to the library, study up, then go down to the Gerard and Goodman's, which is Gerard's, Clipsal, back when that was around in late 60s, early 70s, and buy some parts and come back and construct something that was better.
Wow. So better. Yeah.
Yeah. So that was primary school. So,
wow.
Yeah.
The I want to jump forward a little bit, even though I said chronologically. Like you're an electronics engineer, and so there's all these different engineers. My son's studying mechanical engineering at the moment, but the closest to electronics is probably electrical and mechatronics. But what's the main difference between electrical and electronics? Is it the size? Are we talking about the size of things?
It's electrical engineering. First year there's a lot of basics which are the same, but you then choose a path as to whether it's solid state design as it was back then, or integrated circuits. Computing comes into it. I did a half subject in computing, did a half subject in statistics. That sort of thing. So it's the options are far greater now, because mechatronics is something that's come in between. For robots and sort of machinery. As we head towards automation in leaps and bounds now. It's if we're looking at things today, my area is what I would call radio frequency, or which eventually became microwave radar, that sort of thing. But that's not an area I've worked in professionally for nearly 40 years. It sort of went off in another direction, and my engagement in alternative energy, or batteries in particular, was the fact that there always was a power supply there that never did what it should do.
Have you heard of Philip S. Callahan?
Yeah, I know.
Yeah. There's a book I bought many years ago called The Round Towers of Ireland, and he had a theory about...
Yeah. I've not read it, but
very interesting. And he was I suppose a radio technician, but was instrumental in some unusual guidance systems during the Second World War.
Yeah.
And it's a great book, by the way.
Yeah.
All right, so you're at your primary school, and you went to the local high school in
Local high school. Actually ended up in town doing the last couple of years at college. So did that. And
commuted?
No, I actually was a boarder.
Oh, okay.
Yeah, I actually got a boarding scholarship, would you believe?
Oh, I would believe.
And part of that deal was to run their radio club in the Scouts Hall. So it was like that was the thing. And I kept doing that after I left and went to uni, sort of thing. Until they converted into another tennis court. But
it sounds like you sort of knew what you wanted to do straight away from a university perspective.
Yes and no. I wanted to be a pilot, but it was like electronics was like almost. It was sort of like I know this stuff anyway, and that was sort of ended up sort of specialising in different areas that were more sort of niche. But it was, I must admit, engineering's been the path to other jobs for me. I've worked almost all for manufacturers over 43, 44 years.
Wow,
one way or the other. Yeah,
it seems that engineers are, because of their problem-solving abilities, they just easily move into another industry. Like I know someone who studied engineering, and he's a network administrator, and there's someone else who's running a manufacturing plant, and then someone else who's just anything where there's problem solving. You studied engineering? Oh, okay. We don't care what engineering, as long as it's not civil. No, I'm joking. No,
civil's fine.
No, I'm joking. There's all these jokes amongst all these engineers.
Yeah.
So uni, you've got into uni, and you're studying a degree in electronics. electronic engineering at Adelaide Uni, I assume.
Yeah.
And I assume, I can't remember what I've got in my notes, but I assume it was there, yeah.
Yeah.
Happy days?
Happy days, but had the lust to work. So it was interesting. A group of us, we all knew each other before uni, went in different directions, and most went into defence and worked at DRCS, as it was called then, which is DSTO these days.
What's that?
Defence Science Technology Organisation, but it was called, or WRE, the old rocket range type stuff. So had an association but never worked directly for the government, but that sort of led to started getting involved in, this is over 40 years ago now, in power control, and ended up in Alice Springs for a couple of years working on different projects up there, and that was my first introduction to solar, was in 1984. And at that point we, it's an interesting path that we were looking for circulating pumps that could be used for cooling equipment, but could transfer water, things like that. So company called SolarX at the time, which I think owned by Amoco. Telecom.
SolarX?
SolarX.
I remember we still occasionally see some of the old panels.
The old 42 watt panels.
On the old off, and they're still going.
Yeah, so it's that, and we looked at what the Telecom guys were doing when they were laying out the PSTN and sort of remote, automatic telephone exchanges using panels. So we started doing all sorts of things and got involved, sort of part-time in some community work where we were, designing up a package that could be sent out to a remote area for Indigenous people.
What, combined with a diesel genset and all of that?
Yeah, it was all solar pad water, sort of pumping. Okay. Yeah, it literally, the electronic control that did the thing. It was basically very...
no battery you're talking
no
about?
Battery, no. We're basically storing water.
Yeah.
On a tank stand, put the solar panels on top, had electronics which sat there, which is basically driving a 24 volt DC Honeywell motor, and that turned out to be the weak point. Brush motors do wear out eventually, and calculating efficiencies on pumps and temperature effects and things like this. So it's just water's just another flow type thing, but batteries were just there was one system we did with batteries, but it was an extra maintenance point. We're trying to get zero maintenance.
Yeah, because you're in the middle of nowhere, and so any kind of maintenance requires like a 10-hour trip in some cases, if not longer. So you really want to minimise. So you saw, obviously the early days were, I suppose, the flooded lead acid batteries,
yes,
the eye-wash stations,
yes.
And if well looked after, they had a pretty good life, didn't they? As in lifespan.
Yeah. I worked for a battery manufacturer in the 90s, G&B Technologies, who were originally Pacific Dunlop batteries.
Oh, right.
So that was probably my lead acid era, but was involved in the charging side of it and, let's say, improving the requirements and the some of the other jobs we did a lot of work with it was then still Telecom, their solar pad optic fibre, the east-west and the north-south runs, and they, in the first generation, they had flooded lead acid batteries, and it was effectively a full-time job going up and down the track,
topping up the electrolyte.
Because I don't know if you've ever seen them, but they essentially a hut on the side of the road, solar panels. They were big solar by then, 72 watts, and the hut, the batteries are stored above ground, and then there was a cement tube where the equipment was, so to keep the equipment more temperature stable. The point I used to make was, wouldn't it be better to put the batteries down there and up the top anyway? But there was logical reasons because of the...
Okay.
So we worked on a project where we converted into VRLA.
Yeah.
And that was sort of early days of AS6 2676, which was there was two parts to that. There was the flooded cells and the VRLA,
which batteries. Were the gel-based batteries.
Yeah, well, gel, but they were actually
AGM.
Well, there's two things. AGM, yes. What we found with AGM, what we were using with flooded mat. they were still a lead acid battery, a little bit higher SG, but a crystal converter on top.
Right.
Reason being is temperature. Gel batteries could have been okay, but what we found was that hut's about 45 degrees C.
Yeah. And batteries like to be human temperature, 23 degrees.
Any battery in the world
It's
loves to be in that little bit. Not too cold, not too hot,
it's
just
sort
right.
Of central New South Wales or somewhere.
Yeah.
It's funny, isn't it, that the batteries do, from a chemical reaction perspective, like that kind of range.
Yeah, I'm not a chemist, but we don't talk about sulfating and all sorts of things. But the same company owned Pacific Marine, which were doing the batteries for the Collins class at the time.
Oh, the subs.
The subs, yeah.
Wow.
Back in the So that was I didn't have direct involvement. Same, but went down there.
They'd be big batteries.
Yeah, and because they sit there, they're basically best thing to do with batteries, never use it, but they have a little propeller, so they circulate the electrolyte. But there's not much else different with them. They're and they've been changed once, and I think Pacific Marine or whatever they're called these days are still going, and they make batteries that export for other submarines, so it's still lead acid.
It's funny, like I always think batteries are a dumb device, and the only time they actually produce anything is when they're brand spanking new. After that, they simply transfer energy with a loss. But it's true, isn't it?
Yeah, battery. That things have changed a lot with lithium batteries, clearly. But the problems of sulfation, material, PVC would be attacked by acid, and the sealed batteries or valve regulated, as we call them, ran a higher SG. So there were always challenges on that. Other than the fact you had to have your float high, you don't boost them. In the end, sulphur's got to form in the plates.
That's right.
And that's all the plates disappear. But to be fair, because at the same time mobile phone rolled out, so we're doing those as well. So it was a very busy time.
And that was when the energy density was that was the main goal, because you don't want a phone that big. But I do remember those bricks in the early days where the tradie had the big brick connected to his horn in his truck.
Yeah.
And he's on site, and then because I was helping my old man building when I was young.
We did some and UPSs, and UPS at that stage were transitioning from the 80s of big systems and replacing the battery with valve regulated, but the load upstairs changed. They were running now sort of rack mounted servers, not the old traditional AS360 type computers. So I remember doing one project for defence where we put in a 400 VA, won't mention the brand because it'll identify the site, but UPS, and that was all designed on what the original project had spec'd about 10 years before.
Right.
And when it came to testing, the only way we could test it at full capacity, because all we could get out of the whole building was about 50, 60 kVA, was to hire a big load and hook it up.
Oh, a load bank.
And it was only there was a 5-minute changeover for generators, and enough time to shut things down if it didn't. But it worked out. It had several hours of autonomy because it was just not the load. It had changed in that time.
Why 5-minute changeover? Because that's a long time for the gens to get
enough
the load.
Enough time for them. They run.
Warm up.
They're usually warm. So I have to figure what these had, but they were big Cummins. There was several on duty. But they had heated sumps, so the oil was warm.
Oh, okay.
And a lot in that day would have permanent heating in the water anyway, so they were at spec, tolerance and everything else ready to go. But the automatic starting, and had quite a bit to do with that in the late 80s. Once again, batteries and charging systems, and automated when the fire regulations changed. Where you started to have, you needed, in the end, the diesel, electric. Fires would turn up, power goes off, the diesel should be on load by then, and they much the same sort of thing, automatic starting, and if the diesel failed to start, then you're in trouble.
Hotham Airport, it might not still be totally off grid. It was when we did a job there many years ago, McFarlane Generators, and they had 3 generators. 2 did a 12-hour on, 12-hour off, bang, bang. There was a third one. It had no valves, no dials, and they called it the suicide generator, which is a term I'd never heard since. And it was designed when those two failed, it would just run.
It would just run until it blew up. Yeah,
That's it.
Yeah.
And I was like, wow.
Yeah.
And we had to change these very large 2,500 amp hour 2-volt cells. Huge in a container. But anyway, look, it was interesting because I'd never heard of that concept before. So this all the remote batteries do have this intrinsic relationship in a remote area with a fossil fuel component, don't they? Whether it's
typically,
they still do, and it's probably it's a cost thing, isn't it? We're not at the stage where battery, and we've jumped ahead a bit, where batteries are so cheap that you can go, hey, I'll have 2 weeks of autonomy.
Yeah,
right. And
that's which interestingly enough, that's what Telstra used to.
Well, they did those.
That was the thing.
They had to have it because they weren't going to run a gen set out in the middle of nowhere they run a little for the.
Fun fact is that 30 years ago, Telstra was the biggest user of solar panels in the world.
Wow.
Yeah, and there's numerous projects worked on there. The Isolators project, which all that's left of those. These were 8 foot by 8 foot. Sorry, I'll go metric. 2.4 metre cube containers that were basically satellite earth stations you could drop in at a station or a phone box and get ISDN. It was a project 30 years ago.
That sounds a bit ahead of its time.
It was very low batteries. I wish we had lithium. 24-volt system. But I think at the end we made about 8 of them.
Wow.
And that was a very well-run project management cooperation with the guys in Telstra, some of which still work there, that really were thinking ahead. And it cost money, but I occasionally in travels I will see these containers. They don't have the panels anymore because now there's power and things like that.
Right,
Yeah, that's number 55. Okay.
So you've done a lot of jobs, and I know off camera you talked about certain government jobs, so we can't go there. But so straight out of uni, what was your first job? Like, who was the company?
Worked for an electrical company, yeah.
Yeah, so it was, yeah. And then after that, did you stay there for very long? Or
no, about 6 months, and then.
Oh wow, that is short.
Yeah, and then it was one thing led to another. A manufacturer needed someone in Alice Springs to basically become a field. I suppose we call it a field engineering job these days, but it was a lot broader than that. Let's say called on my farm experience and various other things, and being able to travel out in the middle of nowhere and sort things out.
How much can you talk about that?
A bit. It's probably the bits I enjoyed. It was being involved and doing work in a power station that used World War II submotors to power the whole place up. Things like that. Yeah.
World War II submarine motors.
Yeah.
What are those motors running off? Because I don't know anything about submarines.
Yeah, well,
they'd be big diesel engines.
They're big diesel and lumpers. I think from memory they were doing because it was 60 hertz, not 50 hertz type stuff. So they're doing about 360 RPM. I seem to remember there'd be two or three on duty.
Is that an American motor?
Yeah.
Yeah. Of course.
Give them too many clues now.
Sorry.
Yeah,
but
there was, and they're no longer in use. But it was amazing to see that they were still being used into the 2000s. And there was another site which might have been just south of Woomera that had the same arrangement. That's been offline now for 25 years, but did a project that did similar sort of upgrades, generally around sort of the control side of things and so forth. So not so much, certainly batteries involved, but I wasn't directly involved in that. But that was where the solar thing came up, and we were doing all sorts of things with, remote area power. And then I came back to South Australia, and I've sort of I've done a bit of commercial stuff. So I think the role was called sales engineer. So that means to me it was a field engineer.
But you were actually an engineer, because a lot of people are called sales engineers, and they're not engineers.
That's right.
Much to the chagrin of the real engineer.
Yeah, so that was the fire pump industry. So it was, and literally getting panel boards made, engaged a local manufacturer for all the modules for the auto start and battery charging and things like that, and did that until the end of the 80s, and then worked for a company called Mallory, who owned Duracell.
Yeah, wow.
And then and then
Wow.
looked after all the industrial and defence contracts for them.
Well, Duracell had a...
Well, Duracell went through a buyout. I think it was KKD bought them, so they split it up. So I stuck with the Duracell side, and then essentially looked after industrial defence contracts. You'd be surprised why they use batteries. The old Blackhawks have for call it peacetime flying. All their warning lights run up AA batteries.
AA batteries?
Yeah, because there's no wiring.
Oh.
Yeah, so it's things like that.
What's the advantage of that?
No wiring, so less radar profile.
Right. Yeah.
I think everyone knows that. That's not top secret. And
Yeah, no.
Yeah.
We're definitely not talking
things like
about
that.
anything
Yeah,
top secret.
but some of the other technology like zinc air batteries and
Zinc air.
Yeah, which is sort of a thing that's been and gone because it was like pull the label and your battery works. It was a lot of those sorts of things used in weird and wonderful applications and batteries that powered radio devices and things like that. So.
To me, a lot of the batteries is like beta and VHS. I remember there's a is it the sodium metal or nickel metal? There was a metal battery.
Yeah.
There's so many different chemistries and that vary in energy density and safety and all of that. But a lot of it's got probably to do with marketing as well, I'd say.
There is the more consumer it becomes, it is totally marketing. The two metals that are dropping out are like mercury and cadmium. In fact, they probably have
the
dropped
nickel
out these
cads.
days.
Yeah, they were the early drill batteries. And when I was working for another company years ago, we saw a couple of off-grid ones. We didn't know what to do with them, the disposal of them. I don't know what happened to them.
The flooded nickel cadmiums had a bit of experience with those, but they were definitely on their way out, and that was where valve regulator stuff was going into switch yards, 110 volt DC switching and emergency lighting when it was centralised. Probably 30 years ago, there was all sorts of things, and it was just a maintenance, lack of maintenance. There was there'd be issues that come up because roadies would get in and change the charging settings. It's true fact, and come along 2 weeks later and find the batteries have been cooked. And
wow.
Yeah, it was happening in a few states.
Have you heard of C-Tech?
Yes.
Yeah, they did I used to work for them many years ago.
Yeah.
And they did I think we always used to laugh at the name. It was called the Man Pack, and it was the batteries that were powering the radio comms for the technician.
Yeah.
But that was just a shitty name. But I wasn't allowed in that part of the building because it was that kind of building. I was in the renewable energy division, they called it.
Okay.
And we imported a product you may remember. It was called the Power Router or Power Route. It was a fantastic idea, poorly executed, an all-in-one hybrid inverter charger that had the IP rating of a wet paper bag.
No.
So
not even NEMA. Yeah.
See, the green box.
Yeah.
Wow. Yeah. It's amazing where storage is going, and storage seems to have progressed so quickly, both in energy density and price reductions. Whereas, let's face it, panels really haven't gone that fast, have they?
Panels are.
Their efficiency,
it's
weird.
Yeah, we'll be down to 2 decimal places soon. Sort of 23%, whatever. 24, I believe. Something like that. I must admit, I go around All Energy and just check because I'm a consumer as well, and it's always people go, "What panels should you use?" And it's sad to see them related to dollars per watt. When SolarX was $15 a watt back in the day.
Well, see, when I started in 2003, Queen Vic Market, they were $10 a watt.
Yeah,
and we were using the BP
Solar.
No frame.
No frame.
They were heavy, and we used suction cups to pick them up and broke 3. Yeah. But we claimed they were broken.
It's interesting. A lot of the work done down there stood the time because it was engineered properly.
But back then wasn't it interesting that a petro company had a balancing act, and even Shell at one stage I think had a panel. Yeah. And we were going, well, this is pretty interesting that they're doing that, and then that sort of didn't progress.
Yeah, it's a bit like better to have a hand in it and control it than not.
Yeah, but not now. They're not doing it now.
No,
That's weird.
because it's moved on.
Oh, okay.
Yeah, and you will see some of the probably what I call top tier multinationals getting out of panels because it's there's not the profit there that there was.
I feel sorry for anyone selling them when they have to.
It's a shame.
It is a shame, and they're so cheap now.
Yeah,
they're ridiculously cheap.
Yeah, and they're good.
Well, this is the thing; they are. I did a lot of fishing in Port Phillip Bay, and the shipping channels had little solar panels. Most of the time, they were covered with seagull excrement. But
stuff.
They were old. They've been there for a long time.
Yeah. Yeah.
And they're still working.
Yeah, the UV is about the only enemy of whatever goes into it, and that was sort of lessons learnt early in the day that glass is good and some polycarbonate isn't, and the sealants and the dreaded snail trails and things.
Oh well,
yeah.
Do you remember when that $8,000 rebate in the Howard sort of era?
Yeah,
there was a flood of panels and. Many panels after 2 years, the snail trails, they were, let alone micro fractures.
Yeah, that was sort of later in more recent history, sort of.
Yeah,
we'll talk about that.
Oh, good. Okay, good.
Yeah, we'll talk about that because it was sort of a you'd investigate, and not necessarily was the quality of the material so much as the way it'd been handled and. Oof.
This is a really good point, Dave, because I remember going to a demonstration. There was a company called Red Set. I don't know. Big burly guy, at least 100 kilos. And these panels are strong. Yeah. And he's walking at the demonstration, he's walking around. And a few people are going, I don't really know much, but I'm sure that's not good for them, microfractures.
Yeah.
So that's really interesting you say that.
Yeah, we get photos because inspections were done sort of 12 months after install because the whole point is to see if it's been through a whole heat cycle, everything's still tight. And some of the rural areas, you'd still see the dust marks from the Dunlop volleys across the top. At least they had Dunlop volleys on.
Yeah, I'm sure they had a steel cap on them or a protective cap.
Oh, yeah, that's I'm not an installer. I feel for installers. I think Australia, I have a lot to do with Europe, with my current role, and what we do here is world class. But perhaps if anything, one of the few places in the world where there is regimented licensing approvals, especially for batteries, although it's starting to happen in other countries in Europe. Yeah, but we're in a pretty good environment in a lot of ways, and I would like to think that the boom of 2011 has sort of passed, and then the reboom in 2017-18 has passed, and must admit the quality of installs has improved markedly.
I think definitely, but we're currently experiencing a boom, in the battery side of things. And there's so many stories about, 5 or 6 kilowatts. We want to put a 50 kilowatt hour battery on, mismatching to the nth degree, cheap quality products. So there's a lot of jumping on the bandwagon again.
Yeah,
and that must be a concern. I mean, from a personal perspective,
it is. Yeah, when you see, without diving into too deep, I think what is allowed to be installed is of a certain quality. It's follows IEC standards that didn't exist 10, 12 years ago. So the only concern I have is...
It's a design concern, I think.
It's an installation design, and while the manufacturer can protect people from the battery, the concern's the other way around, protecting the battery from people.
Oh, that's a good point.
Yeah.
And the thing is, if a manufacturer sells a product and he's got recommended, they've got recommended guidelines of how to install and what have you, they can't stop anyone from badly designing a system, can they?
Yeah, there's enough technology there now to self-manage, and we won't talk about AI because that's sort of another thing. But I'd be pretty confident the standards now are evolving, especially fire standards like UL 9540 in the US and things like that. That's pretty tortuous. But
safety is a main concern. Let's face it. At the end of the day, people want to be able to go home to their loved ones after installing a product. the occupants of a house want to know that what they've got is fit for purpose, and also it is safe and it's not going to explode, what have you. And that's the end of it. That's the most important thing, isn't it?
The worst thing is, and this was quoted quite a few years ago, is it's going to become a dishwasher, the battery. It's that common. And that's the level of care and concern it gets. And it still requires maintenance. As we get, like the CCPOS, remote connection, sort of remote monitoring, some companies do that, some don't. The more expensive ones do. As it becomes more proactive, pseudo maintenance, the better they'll be. They're not. It's like a solar system. They're not maintenance free. But
no, nothing is.
What's the first thing gets lost on a site? It's the instruction manual. Guaranteed. I can give you stats. Give you stats.
Please,
please. More than 90%.
Really?
Yeah, it would not.
I knew it was high, but that's disturbing. That's really disturbing.
And batteries, I suspect. In the end, it appears to be set and forget, and it mostly is. But there still needs to be a human element just to keep a. If nothing else, if the light's flashing, it's call someone. Or even better, someone rings you up and says, "Is your light flashing?"
Yeah, but that comes at a cost, and that's the thing, isn't it? Like, what's monitoring? Oh, we're going to monitor your system. Well, what does that actually mean? Does that mean that we'll look at it once a month, once a week, once a day, once an hour? And if we do see something,
you're right. It's still getting there.
I mean, everything's a work in progress, like the Australian standards.
Yeah, and standards, unfortunately, we're going to lead to that, weren't we?
No, I thought I might.
No, well, my little lecture on standards is, standards are just an instrument that a regulation uses, but the regulation's there because of law. So it's law is created.
Can you give us a hierarchy, like for those who don't know, what stands at the top? And where do standards sit in that?
It's the
hierarchy?
Alternative Energy Act 2001 as amended quite regularly all the way down through. So that sets the boundaries, and it has different things in there. It proposes inspections, it proposes a accreditation service, which is currently Clean Energy Council for all IES inverters. The regulations then are usually in Australia, because of our federated system. While there is a sort of national overbearing regulation, the regulation then is directed by each of the states. So you have ESV, ESO, et cetera, around the country. And then they draw on the standards. The standards, in the end, that's the instrument by which you don't get prosecuted on a standard, you get prosecuted on a regulation if something goes wrong. So it's then, and then the regulations are then policed to that standard by inspection services, or and it varies from states. Some states don't have mandatory inspections. Sort of thing.
Queensland, I remember.
Queensland. Like South Australia has ECOC, so it's there's all different ways of doing it. To be fair, each achieves an outcome that is probably better than what you see anywhere else in the world. Just they're all different, which is our, that's...
But they all fall under the mantle of the Australian standards, and they all fall under the mantle of certain legislation.
Yeah.
And at the end of the day, if you don't do the right thing and something happens, you can be prosecuted under that legislation.
Yeah. So it's standard is all about the intent of what the standard... Standards, unfortunately, all voluntary labour, that's why they take so long. And standards have not been able to keep up with technology. Some rare examples, but
it's happening too fast, isn't it?
Yeah.
Especially when you start talking about vehicle to grid, you're talking about VPP, you're talking about these different battery chemistries.
Yeah.
Throw in flywheels. We'll talk about that later.
Yeah. it's vehicle to grid. Knew we'd go there with that. Australia is perhaps one of the faster adopters, and to be not beating too much the drum about how good standards have been here, but in Europe, where you'd think vehicle to grid would be legal everywhere, it's not. It's only in certain countries. It's been held up by effectively the 4777.2 type standards and things. Because it is, once you start to export, it's a generator. So here we do have that framework for VTG. So type 3 or type 4 AC or DC. what the industry is coping with is type 3, which is AC. The box on the wall effectively is your network separation relay, protection relay, whatever you're going to call it. So that's its function. And that's all it does because the inverter's in the car. So the car has to comply. When it goes to DC, it's all on the wall. So it's actually easier, but not easy, because that's still an area where, in the end, it's just a battery you're plugging in.
Yep.
To an inverter on the wall. So
it is, but when it chooses to charge and discharge, is up to probably in most cases now some AI, a bit of basic programming, some AI algorithm that learns. Oh yes, what's going on?
Yeah, that's right. You still need some human interaction.
No, thank gosh.
But it needs to be a qualified human interaction. So you don't want to go out and want to drive to Ballarat and your car has kept half the district up overnight because you're not going to have any. Depending where you set your parameters. So,
it's hard too now with the rise, and I know you mentioned maybe not talk about AI, but we live in this world where it's everywhere. You're talking about AI agents, or some people say agentic.
Agentic, yeah.
Is that a real word? I hate making it up as you go along.
Where we're at, I would hope, is still like machine learning, which is generative, where it needs, it's taking some of the awkward steps out that needs a high level of, it still needs human interaction. Agentic, or what do you want to call it? Real AI, human,
AI
whatever.
Agents, yes.
Yeah. That's a concern.
Here's my keys. Do what you like with my car.
Because the concern that comes up, and been on various government groups leading up to the battery rollout, is just how much AI will impact safety. In the end,
and who's liable?
That's a whole different one.
Sorry, David.
But true, and that's. I did one project which we won't discuss, but it was very much about residual risk.
How are you going to say that in this boat?
But like in the end, my job is to provide a different aspect, and it's you can't say you've seen it all before because there's always something new. But it's a bit like waving a flag, going, "Hey guys, I sort of remember something similar to this, where this is what happened," sort of thing, and you can't be risk adverse. You do have to do a risk assessment in everything you do in the day when you walk out the front door.
Well, that's being proactive. But don't you think, though, and I'm purely asking your personal opinion, that we've been totally reactive when it comes to the AI? And I know we've strayed a little bit from renewable energy, but everything's connected. But we seem to be very reactive, not proactive.
Yeah.
But we're being proactive with batteries. We're being proactive with inverters. We're being proactive with renewable energy in general.
Yeah. Yeah, which is an interesting thing. And AI is, the other concerns about power consumption and things like that. The interesting bit, and this is a little bit about this, is that the trend in all these farms is 800 volts DC. That's how they run them. Mm-hmm. And the power they're using, it's like MV to 800 volts. So it's this whole new realm that's happening over here that's, changing electrical work.
Let alone they're using potable water to cool these bloody systems.
Yeah, that's right.
Yeah. In the second driest continent. Oh, anyway.
Yeah, and that's.
I'm rambling. No, but it's serious.
Exactly, it is. Yeah, and water's a great coolant, and it's been there, done some of that.
But you've been.
Yeah, well, that was sort of what that's the first solar stuff. We were using water to cool things.
Right. Can you expand on that a little bit?
Well, just simply, you can imagine you've got a closed loop, and you use gravity to feed. So, the device might have torque in litres, 20 kilolitres of water sitting there. So you're guaranteed a flow because you've got gravity. It might be, they were about 10 metres high. So you got 100 kPa pressure, which is enough. Hydraulics.
Yep.
Can read a chart and run a slide rule and work out what's
the
required.
Noise equation, all that stuff.
And there would be a pump that pumped the water straight back up. So rather than using the pump, and if the pump failed or stopped, you had a problem. But the whole, the solar would run 4 or 5 times, 4 or 5 hours a day.
Right.
Pump the water up the top. And there'd be several days worth of water up there. So if there wasn't any sun, you had plenty of time to do something. But
there's your days of autonomy.
So that was actually the very first solar project I did in 1984.
But what was it cooling?
It was cooling a transmitter. Yeah.
Okay, we'll leave it at that. Yeah. I can see the look. No, it's really interesting because a lot of most technology seems to arise from the military, doesn't it? Like, I'm not sure about solar panels because they've been around for a fair while. They're used on satellites, aren't they?
Yeah, and that's those that aren't nuclear powered. Yeah.
What, the satellites? Really?
Little tiny, yeah.
What, by themselves, or are they in conjunction with, say, a
They're
high-tech lithium battery?
Most of these days are solar, full stop. But they're back in the early days. There were certainly
Tiny little nuclear plants,
tiny little,
around.
and not not in the same sense as you would think of but certainly.
Wow.
Yeah.
Now the cells that I'm jump back a little bit to the solar panels. The cells that they were putting on these satellites, they're a higher grade, 35-40% kind of stuff, weren't they? Is that right, or am I?
Well, not really. I don't think so. I'm not. I've had a little bit to do, but not to that level. It would not be. If anything, they have to be massively lightweight. And probably the biggest issue they have up there is tiny things hitting them, and but I would not expect the efficiency to be too much different. The only thing is that when they're in the sun, they're extremely hot, and when they're in the shade, they're extremely cold. So,
yes,
it's and a cool solar panel's not a problem, but it's not going to be in the sun, so it's not working, sort of thing. So there's all these other, probably mechanical issues with them. But the interesting bit, there are satellites up there that are solar powered that the batteries have drifted away from. And
what do you mean?
Well, the batteries died. But the satellite still works when it's in the sun.
It doesn't work when the sun's not hitting it. Okay.
And the power system is such that it was just floating. Nothing different to what we do on a roof these days.
When you say floating, what do you mean?
Oh, maintaining voltage. Old lead acid kicking in. So running it at a nice, steady, not 100% charge sort of thing. A bit like your 80% you do these days.
Gotcha. Yeah, with the lithium, which is weird when you start talking about the actual capacity or usable capacity of these batteries, when ideally they have to be left at 80 or 85.
80 is fine, but it's partly about balance. But the interesting bit, this, I've done a little bit of this in recent times. They're amazingly balanced. Good quality batteries are within, and you when a car talks about usable capacity, it's in that little safety zone. So you're never taking it down low. So the bell curve on where the voltage is going to go outside of that is, you're well and truly within the bit. It's all about balance. That's the BMS is the most important part of the.
Everything in this world about balance? It's starting to get philosophical. But it's true. Off camera, we were just talking a little bit about standards and stuff, and David pointed out an interesting thing. Look, bit of a backstory. David's had a lot of input and continues to have a lot of input on the Australian electrical standards. He's very well placed to make comment. So he was mentioning the difference between the American standards and the Australian standards. Could you sort of elaborate on that little one?
It's the bases of standards are sort of come from different areas. IEEE is probably the main Electrical Engineers Association for standards. So things. One standard we're picking up here, CCPOS, is based on 2030.5, but the general electrical standards are developed by the NFPA, it's the National Fire Protection Authority. So it's comes from a different direction, and this is, it sort of goes without saying it. Their aim is to make electrical systems safe in buildings from a fire protection side of it. We certainly have interaction from the fire guys here, and they're very important in it. But it's the main difference in the writing of the two standards, and the bit that comes out there was what's called rapid shutdown. And it sort of acknowledged that two things happen when there's an emergency. All the training goes out the window, and you just want a simple procedure to shut things down.
Of course you do, and we talked about it. You want a big red button that you can go bang.
And the thing, my way of thinking, not always shared by all people, is that you reduce the number of choices that people have to make, especially in an emergency situation. You need things for maintenance and this and that and everything else, but the last thing you want is a sequence of switches that, if you don't switch them in sequence, you create a even bigger hazard. So
wow.
And rapid shutdown isn't a be all end all, but it certainly has proven to be, it takes 30 seconds. It's in its third interaction now, but essentially shuts down all inverters, so it's safe below, basically down to below ELV voltage levels, things like that. So you can walk on a roof. The rooftop isolator, I was never a fan, and we knew it was a problem even when the 2014 standard came out. The biggest problem is it was putting an isolator on the roof that was never designed to go there.
And, in an extreme environment, effectively,
And you can draw a straight line, rainfall versus failures.
Yeah.
It was even if you had the best quality installation, it still gets in there. Hot, cold, sucks in.
Even though they had a pretty high IP rating, it still
sucks in. There's nothing perfect. You could see certain installers would come up with pretty good ideas to to
negate that.
And I know when we did the last update, the standard, we allowed like pressure drainage valves and things like that, because hot cold, you're in the, say, Darwin, good example, Cairns, where you've got 100% humidity, and it just as soon as it contracts, it sucks moisture in. So within 6 months there'd be a high tide mark inside the.
Well, how can they claim to have such a high IP rating if that still happens?
It's an IP rating when it's manufactured, because none of the apertures have been taken out. Right. It then relies on a gland to be mechanically installed, prepared, mounted in such a way that the water can't, the last thing it's got to hit are the contacts and so forth.
Yep.
There was the sunshade idea, that was to reduce the heat on it, so it was less. There was a lot of different things tried, but in the end, you'd have to test it.
Yeah, gotcha.
You'd have to test it. Stick it in a bucket of water and come back 3 weeks later and see what happened. And you can't do that on its own.
You're right.
Yeah, and you can. The interesting bit we found is that the conduit that links top to bottom, there was an equal number of failures at the bottom, because even if you installed it correctly, the water got to the level of where the conduit is and ran down the conduit straight to the isolator down the bottom. And in fact, there was probably more failures.
Well, I mean, obviously installers like it because there's one less thing to do, and there was it's quite time-consuming, and putting these isolators on, not to mention altering the rail length of the top rail, all of those other things from a calculation perspective. But again, it's the standards that we talked about before. It first and foremost should always be about safety.
Yeah.
How long have you been involved with Australian standards, and what has been your actual roles, and what is your actual role right now?
So Australian standards would go back to the battery manufacturer days, where I would be if our nominated person couldn't be in there, I'd stand in for them, created content, but certainly involvement with standards as in using them goes back to 1986, the Yellow Book sort of thing.
Yeah, right.
But certainly, probably, I was involved emergency lighting, the changes around early 2000, because the company I work for at the moment did emergency lighting. In fact, I've got probably 15 years in that, on and off in that area. When the Running Man became a thing, that was 2005. We started using Running Man in various commercial projects and some tunnels and things like that. So it was, if anything, it was sort of trialling things, and probably the main kickoff was in that time. The company I worked for at the time had an office in Hong Kong. I did a study tour. This is sort of 2002, 2003, around that time, when it had changed from British ownership to Chinese and became the Hong Kong Special Administrative Zone. So I did a couple of lecture tours up there talking to engineers about the safety standards and things, and a lot of the stuff that went into the new territories, all those buildings and so forth. And it was an eye-opening thing seeing what was happening. The interesting bit was the older engineers were very much speaking in Cantonese. The younger guys had all gone to Melbourne or Adelaide or Sydney uni.
Right.
And that's they just wanted to they were still running under I forget what it was, 549 or something like that, the old British standard, and they wanted to move their standards on and be involved. And it was, once again, batteries were sort of a part of the whole thing, but they were moving from what were central systems to single point units, which of course is been the mainstay now for nearly 30 years.
And when did your interest in renewables fully kick in? Was this way back earlier, like when you were playing around with the solar panels?
Yeah, it was then, and then certainly in the 90s. The work with mostly the carriers, with their solar rollouts, and that was probably the main intense. That was the job, full stop, and that in the end. Went and worked for an American company called Thomas & Betts, and because they were a manufacturer of emergency lighting, single point units, that sort of thing. So right at that transition, worked for them as a general manager, and then ended up being their national marketing manager.
Okay. You've got a look on your face.
Yeah. I get a lot of that. Yes. And it's interesting, but it was sort of because it was a technical product. That was the way, and that was here in Melbourne. I was here for quite a few years, and that was it was actually a very interesting company. They eventually, Thomas & Betts bought a company called Stanley Electronics, who did defence stuff, so there was a bit of background history in that, but they're now owned by ABB.
Okay.
But it was a good mix of traditional sort of electrical MV stuff, elastomole, which is, I think most DNSPs, utilities still use the elastomole stuff for MV distribution, all the boots and things like that.
Yeah, right.
So it was there was a good technical outlet, but in the end, I ended up being the marketing manager.
Did you have fun?
Yeah, I enjoyed it. It was like a break from engineering, and it was one of those things, fairly good with maths, but you could pick what really was important.
Yes.
Once again, the field experience of what
There's
really.
There's a lot of psychology with marketing, isn't it? It's understanding the human condition.
Yeah.
But at the same time, as you said, it's a technical product, so you're still exercising a bit of that, the engineering brain.
Yeah, I had done some, we'll call them post-grad business communication stuff, just TAFE level sort of stuff back in the late 80s, and that was sort of. Back when there was a 1% levy on training and things like that, and that was put my hand up for that. And I think that was a good thing, because they went, oh no, can you go explain that to that person? And go, okay, yeah, I can, and help them out. But it was I found it quite. It's like in the end, it was the company was changing, so I actually moved back to Adelaide in that period of time, but I was there 7-8 years, I think.
Oh, that's a fair whack.
Yeah.
It's funny nowadays, people are moving around left, right and centre after very short stints, which I find quite strange, but, each their own. Now, I would like to get back to the standards, but also I want to chat about Enphase. Okay. Because that's how Sam Chanter from Enphase, big shout out to Sam, and Duncan, because Duncan's going to be coming on.
Yeah, Duncan's a legend.
He is a legend, and he's been in the solar game for a very long time. Sam said, oh, look, because I was chatting to Sam, I said, come on. And he goes, no, but I tell you what, get David to come in, because he knows Enphase really, really well, and he knows a lot about a lot of stuff. They were his actual words. So this Enphase, how did the Enphase thing come about?
Enphase, I first came across probably in about the first 12 months of them operating in the country, when they were. This is like 2012, when I was at Le Grand.
That's right. That was a long time ago.
And part of that was that we had an inquiry come through here for phase failure detection, and Le Grand has this little module which is basically, it was actually a phase coupler, so it's technically pretty simple, but what it would do is couple the PLC from a single phase across to other phases. So a little DIN rail mounted module. So they started using those. So that opened up my curiosity, and you sort of dig into it and go, okay, that's pretty good. Okay, yep, understand the way this works. So I sort of become a bit of a fan. A few of my friends put Enphase in, because on my recommendation, I'll give this a go. You got, there was the shading thing that was driving it back then, but the reliability was good, and Probably the next big thing was like 2016 when they started bringing out AC batteries. So little tiny unit, little ACB.
That was their niche back then. Well,
Yeah.
they were the only people doing it. I
It
think.
was, which was interesting when we were doing the battery standards. That was sort of the only, it was before the Tesla Power One and so forth. That was sort of the only, and being involved in inspections, we did some tranches on battery before 5139 came out. It was based on the second draft and just to road test it literally. So that was sort of, I was on standards and they started chasing me and I resisted for a long time.
But eventually you gave in and...
Yeah. And it was sort of one of those things you'd sort of, know about Enphase, yes I do, blah, 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 blah. I knew their product back to front. It's seen plenty of it out in when the inspectors sent in their stuff, we'd have a look and go, okay, that's interesting. Oh, they've got an IQ7 now. What's that? It was certainly around it. Knew the people, knew the GM at the time, and the rest is history. So that was 2019.
What sort of battery chemistry are they using?
It's lithium iron phosphate.
Yep. Yes.
They've always used lithium iron phosphate. Yeah.
It seems that that particular chemistry is really the go-to because not so much because of the energy density because it's not as dense as the other ones, but who cares really? Yeah. I mean, you only really care about that when it's in a phone or laptop.
Yeah.
It's not like it's a flow battery which takes up huge amounts of space. So it's the safest technology out there, and they're sticking. How are they looking to, without giving anything away, are they looking to improve the particular lithium iron phosphate battery they're using? Are they looking at other technologies? It's
riding the wave of the ACBs started off with a beautiful Japanese battery, but it was probably size-wise quite big compared to what it did. Now it's more about as much energy density as you can get in a square litre, essentially. It really, the balance of things, because batteries are lowering in cost, becoming more common. The quality's always been pretty good. I do get to look at the 10-year-old batteries, and generally a battery you rate to like 80% capacity point, and the reality is the predictions of them lasting 6,000 cycles and things may even be conservative.
Really? Because I always defer to, remember when LEDs came out? They said 100,000 hours, and that was bullshit.
Yeah.
Well, sort of it was. They halved it very quickly in a short space of time. Obviously, batteries, their lifespan, and that's a caveat in most warranties, is based on their charge and discharge rate and how many times they do that per day. And now it seems that the race for the batteries from a VPP perspective is that, a pretty good C rating to send it out pretty quickly. What's your view? I mean, how does a battery have a better C rating? If it's a lithium iron phosphate battery, how does one have a better C rating than the other? Or do they all have the same and they just give them different ratings?
Depends how you put them together.
Yeah.
So it's a conventional sausage roll, sort of wrapped together. So
the 1865s, most of them, aren't they?
Yeah, although what we have is pocket cells. So pocket cell is lithium pocket cells. So most of your 18650s and 21700s and the bigger formats they are a wrap.
Yep.
But there are some life batteries we use pocket cells.
And
it's just the surface area. In the end, bus bars, how much the internal resistance, the lower battery technology doesn't change.
Yeah, and the chemical reaction is the same. It's the same chemicals involved. And for the people who don't know, can you sort of explain? People, you hear lithium iron and ION, and you hear lithium iron, IRON. Can you just explain to the people out there?
It's probably the two different technologies, like NMC.
Yep.
So nickel, manganese, cobalt.
Yep.
So that's your your typical 18650 cell, which has been in laptops for 20 years, and
Right.
is what everyone is familiar with, and early model Teslas used, and all that sort of stuff.
Yep.
Yeah. Lithium iron phosphate. It's actually ferric phosphate.
Yeah,
but,
so
LiFe,
LiFePO4, yeah.
No cobalt,
Right.
no nickel.
Right.
Still lithium,
Yep.
but so hence it has a different voltage point. Instead of 4.2 volts, it's 3.6 nominal,
Right,
so
right,
it's slightly different. Yeah, and there's other lithium batteries. Lithium batteries have been around for years and years and years, 40 years ago.
Probably longer than people. Well, I didn't know. 40 years.
Well, they were used
wow.
in the military, because it's a light.
Right, yes.
But very expensive.
Yep.
Lithium manganese oxide. That was
Yep.
sort of your coin cells. They've been lithium. They were silver oxide, then they went to lithium manganese.
Right.
Yeah.
That's really interesting.
So and
So do you think because they've been around for that long, that's why the quality of these batteries, all in all, is pretty robust?
yeah,
Good?
life batteries have been around more than 10 years.
Yep.
In MC, it even longer than that. It's one of those things. It's like we're probably now getting towards the if you talk about a J curve on products and things like that, it's mostly they're looking for the next solution. But the life on lithium batteries is mentioned before. The caveat on a battery lasting that long is it's looked after, and that's mostly taken care of by the battery management system that
Yeah, the
makes
BMS,
things to keep it balanced. It's not overcharged, not over discharged, and all batteries are the same. The less you use them, the better. The longer they last.
And the perfect, the right temperature as well.
Yeah, temperatures are, when they're cold, they don't work as well, but that's not a life thing. Lithium phosphate really is better. It's less susceptible to thermal runaway.
Right.
But once again, that's also dependent on the construction of the cell and things. There's a whole heap of other factors come into it. But it's the reality is in a fire test there is a temperature which you can set fire to it. But most battery fires have been the battery catching fire because of something else.
Okay.
Yeah.
Okay. And that's really interesting. Can you explain to me, like you mentioned, Enphase uses the pocket cells. Are they like a physically different?
It's just it's rather than a spiral, it's just a flat.
Okay,
It's just a
right.
flat.
Right. You can
Yeah,
just
more
slide-
traditional. Yeah,
Oh,
yeah,
okay.
yeah,
You
yeah.
can slide them in your
Yeah,
pocket.
because they're in a silver pocket.
Right.
Yeah.
Right. Now I see. I
Yeah.
see. Yeah. And so they've had their this battery system for quite a while. They've obviously they spent a long time going through the right processes to select the right battery. And were you helpful in that respect, or you came in pretty later on?
My bit's sort of involved in the transitional safety of it, and now even less because my job would be to advise the teams on what standards are required.
Right, at this
there's
point, no.
manufacturing and more importantly the installation standard, because in the end you have to make a product that can be legally installed.
Absolutely, and then go through the rigmarole of getting it listed, and like an inverter, like also that the process for the inverters is an expensive process. This is not cheap, is it?
It's my comment about Australia. It's the most expensive place to homologate, which is the same as a car homologation. In other words, getting it accredited, the most expensive
I
place
have
in the
to
world.
admit, I don't know what that word means.
Homologation is basically aligning standards with the requirements for listing.
Right.
So it's a big word.
It is. Yeah, I mean, I'm pretty okay with it, but I hadn't when I put the brief together and I went, I don't even know what that word is.
Yeah, it comes up in the car industry. If there was racing at Bathurst or something like that, they'd have to make 25 or 50 of a particular car to homologate it. In other words, it wasn't a special.
Right.
So it is really it's like a type approval.
Right.
Yeah.
Okay. Yeah.
And type approval is here's the type, and it essentially there'll be requirements. If you use the European example, which we follow, is that you have a safety requirement.
Yep.
So that's ERAC.
Yep.
So that's electrical safety. So the product itself has to be safe. The inverter sits under a standard called 62477, which is an umbrella standard that Up until very recently, it just referred to the UPS standard because that was the nearest fit. 5 years ago, there was really no battery energy storage standard, full stop, but it still fits under that side there. And then so that's the inverter. The battery itself sits under 62619. So that's another umbrella standard, which is one that sits under that, which is 63056, which is specific to batteries that are used in battery energy storage systems. So they're the two: safety, EMC. So that's more operational around the inverter. So that's much the same 61,000 series across the whole lot. And then, lucky last, but perhaps most important, is the grid connection standard. So that's for inverters for PV, it's 62109. So it's similar, but whole nest of standards, which and 4777.2, which is the inverter standard, pulls together battery storage, PV, inverters into the same area. The grid aspect on that is now down to Australia A, which is the NEM.
Yep.
And then you have Australia B, Australia C, which WA runs B, and C is in other parts. Although there's less and less difference between those different settings. So that's protection settings, what we call advanced grid functions, which are the grid protection, grid support type things, and so forth. So Australia has just about everything turned on. It would be equally the most complex connection requirement, and hence expensive in approvals. And the other end, the Clean Energy Council, have a lot of checking to do.
It's interesting because you go back not that long ago, and batteries were effectively they fell under the mantle of UPS in a renewable energy. They fell under this maybe UPS and off grid. There was the odd customer domestically who had go batteries on the grid and probably using a Selectronic product, AC coupled, DC coupled maybe, or a combination of both, etc. But now the standards have to take into consideration that batteries are getting absolutely huge, as big as the inverter side of things, the grid connect, because we're seeing C&I spaces going, maybe it's time to get batteries.
Yeah.
Solar farms, arbitrage, FCAS, wind farms. It's batteries are not going anywhere, and we're just going to see an increasing uptake.
It's interesting. It's like it crept up on us because once upon a time we had to talk about ROI, and it was like, is there ROI in batteries? Now it's become. I've got an electric car. I need a battery. It's become the dishwasher. That was sort of the talk we had about nearly 10 years ago, becoming as common as a dishwasher. Not saying it is, and certainly a lot more safety required around it, but every house will end up with one.
That's true. And even now, you're looking, if you want to talk IRR and ROI, you're looking at situations where the batteries are being put in without any solar at all.
That's the interesting part, and then it becomes how big's your service, and
absolutely.
You know the rest. It's
absolutely
because it's not that money. As soon as there's any sort of incentive,
yes,
it's the incentive has got. I would call it automatic gain of times 3.
Yeah,
because suddenly 3 times the number of people are interested, and they find the money.
Absolutely, they do.
And we've gone past the bleeding edge.
Yes.
The next door Jones stuff. Now we've got mum and dad.
Yep.
Going, kids come home. Oh, when are we going to get a battery?
And then when they start with the VPP, and the distributors, of course, are rubbing their hands, going, "Well, we don't have to spend any money on improving our infrastructure because."
Yeah, and home consumers on a not a 5-year plan. Once upon a time, networks 20-year plans have to be or more. How do they cope with that? And that's I call some measures positive measures towards promoting the technology. Other ones I'll call handbrakes.
Yeah.
And the handbrakes are there because there's no other way around it. The economy of scale, the cost to do things. The more remote you are, the bigger the area you've got to cover, the more expensive it is.
Well, tyranny of distance when it comes to Australia, doesn't it? Like with anything.
Yeah.
It's look, it's a really interesting one. Like, we're involved in doing some battery jobs, batteries by themselves on the grid.
Yeah.
arbitrage.
Mm.
FCAS less and less. And there's pros and cons to both approaches. Some complicated systems have both. I don't know how they work that one out, but anyway, strange AI algorithms or what have you. But it's funny with the arbitrage side of things. You're talking about the speculative nature of trading.
Mm.
You know, buy now, charge now, discharge now, and it's all weird and wonderful. But at the end of the day, having that stability is a good thing. I suppose.
It's interesting because Europe is sort of in my realm, and I've probably at different stages of the last 6 years spent more time on Europe, and I get to go there every year, which is great.
Yeah,
because
I've
we
never
have
been.
offices in Lyon and France. And
you speak French?
No. I speak some German. Yeah,
yes. That's an engineering language.
It's sort of it's a long story in that, but you've certainly had to be familiar with it. But I need to be there for a few weeks for things to kick in.
Yeah, right.
Yeah, but it's been interesting seeing. There's certainly there are leaders in that area, but the arbitrage type thing is only just becoming a thing in certain countries.
Yes.
And, if anything, Europe is sort of organised, but not. It's 27 countries that effectively follow what's called Rule for Generators 2016. So it's a common setting, and there's a standard in 50549-1, of which there's a test standard -10 that we're just starting to look at here now, because it's sort of an industry standard that if an inverter's tested that, when we look at Australia, most of the things that we need for Australia has been tested.
Yep. There's
just a few other things, but where the unit, the united front of the grid in Europe disappears is once you get to certain countries and things like that. So there would be 7 or 8 countries that tend to lead this sort of thing.
Right.
And then the rest are sort of still in catch-up mode.
Do they all have the same voltage?
Yeah, it is 230.
Right.
For most things, for inverters, batteries, all that sort of stuff, the standards we now have with TS5398, the tech spec for safety for batteries, it's basically the European standard with a few variations for Australia. The reason the variations is we are ahead now, clearly, to where Europe is.
What, technologically or in our uptake?
Our uptake and our technology.
Really?
Yeah, we're the test case in a lot of ways.
Interesting.
Yeah.
That's really interesting.
We're the test case. Yeah.
We're the first for once. Oh, sorry. No, I'm joking. We're actually the first in a lot of technological advances.
Yeah, that was the problem with 5139, which when it came out, there was nothing else in that area. And And you may remember it came out twice. The first one, it attempted to be an inverter battery standard, like a manufacturer standard and an installation standard, which in the end they got split. You got the battery best practice guide, which picked that bit up, and you got 5139. And it was 5.5 years. And there wasn't, to be fair, it's not perfect. I don't say it's perfect at all, but and the amendments have tried to clarify things, but the wish list is still there to move it forward, and it's now 6-7 years old, so it's one of those things. I think what we're doing now, hopefully we can learn a lot more from and tune it up so it is a appropriate standard that keeps at least relevant to.
Well, for those who don't know, what size battery capacity is 5139 applicable to? Yeah,
it's basically it's like the same as 4777.2, so 200 kilowatts is, and two sides to it. There's the actual storage capacity.
Yes.
It's still going to be used for guidance above that.
Right.
Same as 4777 is used for guidance, but there's moves afoot to bring in an IEC standard above 200 kilowatts.
Yes.
Which you may or may not be aware. I probably can't talk too much about it, but the reality is a good thing. We just have it's an established IEC standard that we will adopt, I suppose the best way of putting it, with local modification that will take some of the ambiguity out of what's above 200 kilowatts.
And that's what you said before. We're moving at such a rapid pace. The standards are living documents. Of course they're never going to be perfect. It's like saying, I'll wait till the software is 100% before I release it. It'll never get released.
It won't. It'll fail. Yeah, it first and foremost, safety. Nothing goes
absolutely.
out unless it's safe. And safe includes what we call functional safety, so that's software.
Yes,
And
yes.
it becomes more and more important, and we're not talking about AI here, but the question comes up a lot, especially in government forums, about what's the impact of AI going to be, and it's safety as precedent. There's a pecking order.
Absolutely.
Yeah. If AI, and this is the thing about generative or agentive or whatever, the reality is if it takes a common thing where there's 100% that's what has to happen every time, that's fine. But it's really just machine learning. And if you really look at it, it's programming that's been put in there.
Yep. But now it's a case, and I was listening to a podcast about jobs and where they're going, and they mentioned lawyers, a lot less work. In other words, going through reams and reams of certain documents, and also the programming, because programming is done quite well by AI. But if you speak to programmers, the code that they produce, AI produces, is pretty dirty. It's not clean and concise.
It's not.
It's not. It's just. It's not best practice. It just gets it.
It's inefficient.
Yeah, exactly.
That's the word.
Inefficient. Yeah.
Yeah.
And not to mention that we're talking about renewable energy sustainability, trying to modify our behaviour in regards to consumption, carbon accounting, all of those things. Scope 1, 2, and 3. A million things that we're sort of we have to experience now. But it's great that that people are within the standard, and it is voluntary, as you said. These you don't get paid for
no,
and that's what people have to remember. Like it's experts getting together and discussing things, and agreement's not always going to be an easy process.
Yeah. It is very much committee decision, and the voting. It's standard in IEC standard Australia. Like you need at least 80% of the quorum.
Oh, is that how it works? Yeah, right.
And in all the meetings I've been in, we robust discussions, but they're from experts, and there's
who know their stuff.
And there's always an intent for a standard. Standard is there for a reason.
Yep.
It's not there to prosecute people, because it's just you got to set the bar somewhere.
Yeah, of course you do.
Yeah, and you've got to be progressive enough that you don't lock out new technology. So that's always the hard thing, because we try our best, but the one difference that certainly in the last 5, 6, 7 years is involving a broader audience, involving installers more.
Yep.
So there's a balance of what happens, and to be fair, the regulators, they have a mandate to, in the end, it's got to come across their desk if something goes wrong, and there's some pretty good depth, and even amongst their groups, quite robust discussion on where things need to go. It's no longer an esoteric, led by professors and so forth, where great ideas, but there's practical experience. Someone will say at the end of the table, that won't work, why don't we do this? And everyone goes, yeah, that's a good idea.
Yeah, right.
Yeah, and just pure practical experience. Once again, hands-on experience.
How many hours? I'm tempted to ask, how many hours on average? But it doesn't work like that. For instance, 5139. How long? How many hours were you involved yourself personally? In that?
Probably it would be. It depended. If you're in the main group, it may be like a monthly meeting. If you're in a working group, it's weekly.
Wow.
And typical meeting.
And you were in a working group.
Yeah. And there's a few other standards I worked on where I've been the drafting leader, and you end up, instead of having a group of 20 or 30 people in a meeting, Pareto's rule, 80-20, only 20% are doing the work, the other 80 are monitoring. And to be fair, they're there for a reason, because their organisation may be interested in what happens. If something's got a disadvantage them, they need to go back, discuss all that sort of business. In a week, it's my current role. It would be at least a third.
Wow.
Of my working time, and that includes IC meetings. So I sit on a lot of the IC mirror committees, analysing IC standards that come in. So we review everything that comes across look at what's good, what we should adopt, what we shouldn't adopt, how that's going to impact us. If there's a change in direction, like we're sitting at here, and there's a standard going to change here, and we've referred to it here. What's the gap between the two?
Yeah, that must. I mean, that because there's a few electrical standards out there.
And the aim is not to make Australia that much different, but we have a fairly unique. We've because we're leaders. In a lot of things, we're sort of out, not on a limb, but I think we're in a pretty good spot. But luckily, we're a big enough market that it's every manufacturer, bar one or two.
It's commercially viable for them, to come here and because I often wondered about that because we only have 27, 28 now, 27 million roundabout, and yes, we have high solar adoption, but we're a big country geographically, but there's not many people. So that's really interesting.
We're viewed as being early adopters. Well, not so much early adopters, but I'm trying to think of the bleeding edge. Certainly, there's reputation that we will lead on things. Some things will, some things don't. Europe knows a lot about what we do here.
Right. Okay. They're watching closely.
And they have to. Their biggest problem is that there's English is not the primary language in either of those 27 countries.
Yep.
So there's a lot of Central European countries still getting there, but in fairness, they are actually doing really well because they've probably started with a cleaner sheet and haven't.
Central European. What Hungary?
Hungary,
I haven't been
Romania.
to Europe, so I'm trying to work
Hungary,
out.
Romania. So everything.
Right.
You can split it because there are actually separate grids. They're not all one grid. So you got the Western grid, you got the Baltic grid, things like that. So what would have been the ex-Soviet countries? They are.
Lithuania, Estonia.
Estonia is very technical. Very technical.
Yeah,
They have their standards organisation's very small country, 5 million people, something like that.
I don't know,
but their
small.
standards organisation provide standards at a discount rate to their students to educate them. They just
I don't want to go there.
Yeah, sorry. Oops.
I don't want to, because I tell you what.
Yeah.
It's
that's the key.
There's so much.
Even New Zealand has PAS, publicly accessible standards. UK does. They
when you're an apprentice, you get them for free. But otherwise, now they're doing it's almost like a subscription base, like everything else, because it's a guaranteed income stream. And I don't.
The good news is that the what we call a tech standard or tech spec, they are being offered. Some you'll have a look. SATS 5398. A few of the others, they're free now. So that is happening. To be fair.
Okay.
Good. Unless you have some sort of part of a company and you can access standards, IEC is the worst. If it's anything to do with electric vehicles, it's €1,000.
Whoa. Which is what?
Which for a manufacturer, it doesn't sound like much, but how many standards do you keep in? And they're all single or 3-person use, so they have to be secured. And
we're ISO accredited as well. We have to be held to even a higher standard, and of course we have all the applicable standards and then some. But again, it's understanding them, making the time for our guys to understand. Well, these are the changes from the last AS 3008 or whatever, and how does it apply to what we're doing? And Sam upstairs, you met Sam,
yes,
one of the engineers. He mentioned in regards to, I sort of caught the conversation. I can't remember. I think it was in regards to connecting buzz bars. I think. But so
on big battery
on big batteries, and that's what we're tending to do. We don't do any domestic. No, we do the decent size, not huge, but big enough.
Yeah, which is a growing area.
Well, it is. It is. It's like I equate to these. I equate various, for instance, right now with the batteries to like the early days of the sub 100 kilowatt connect. There's money to be made, and then eventually that'll be saturated, and you move on to something else.
Yeah.
So now, one of my passions, and I have a friend who's involved with them as well. It's an energy storage system, Flywheels.
Yes, valid technology.
Absolutely, been around for a very, very long time. 25 to 30 year lifespan, bugger all, for want of a better expression, maintenance, very safe, recycled materials, and the ability to discharge very quickly, which has certain advantages when it comes to FCAS and arbitrage. Do you know much about the flywheels out there?
I know a bit because at Torrens Island we've got some grid stability flywheel stuff. And to me it's a closed loop, bit like the pumping the water thing that we did back years ago. In the end, it would come down to investment cost, I suppose. You can make bearings last forever, and zero emissions.
Well, this is the thing.
And you hook an inverter up to it and away you go.
That's the thing, and there's certain advantages. The temperature differentials. You can be dumped in the middle of the hottest Australian climate without any degradation. What seems to have happened the last few years is a company called Amber Kinetics, and that's the one that my mate's involved in. I mean, he's used them. He does some weird and wonderful stuff with dairies and all sorts of weird stuff. And it seems that they've come a long way because of the actual that maglev technology with the bearings. So their self-discharge is pretty low.
Yeah.
And but the cost per kilowatt hour delivered, forget about the lifespan, is still prohibitively expensive for anything but specialised kinds of situations.
Kind of where solar was 30 years ago.
Yeah.
You used it. Hence the Telecom Telstra.
That's
example.
right.
You used it because there was no other alternative, and it worked. But it is definitely an area which will grow. You're getting, if you can get your energy losses down in bearings down to the inverter technology it plugs into it is already there.
Yeah, absolutely. He's got systems out there. So they use a variety of inverters. I think the one that he uses at the moment is a Day, and this is no plug for Day. Is it Day? DEYE. Yeah. But it's such an interesting area because from that much used word sustainability, the recyclability of it. There's no chemicals. You're talking about RF, ferrous. It's pretty, but financially, finances is what drives this all industry, and that's the reality of it at the end of the day, isn't it?
It's starting to rise because I've seen in the IC world, and be TC22, the power converter side of it. There's certainly discussions, proposals, wind generators there, the whole range of different things. But it's on the radar. It's one of the that means manufacturers getting their heads together and going, okay, we need to start looking at standards, requirements, things like that. It's a crossover with mechanical, of course, but it's flywheels have been around forever.
Well, for nearly 100 years. I mean, they were in. I think even Formula One racing cars use a tiny little flywheel, and I believe maybe even some. You know better than me. Maybe some satellites as well. I don't know, but they've been around for a while.
Is the gyro
they'd have the lightweight carbon spinning in hundreds of thousands of RPMs, because it's all about if it's more mass, it's less RPM.
Correct.
F equals MA and all that stuff. So, but to me, it's fascinating because it is a storage technology, but it's not chemical. So. It has its place, and hopefully we'll see a bit more of it.
Yeah, I think the diversity. The other one, hydro pumping and things. Our problem with that is we don't have many hills around the place.
We're an old continent,
and water's a resource. And,
yes,
but seen different discussions about tidal stuff. Maybe Northern Australia to work. It's the maintenance angle. It's just
it's
got
a
moving
severe
parts.
marine environments are severe, and they've tried. There's been quite a few, attempt wave power, tidal power, but I tell you what, expensive, and even with 316 stainless, these things don't,
It's always going to corrode.
It is always going to corrode.
It's always got to, and it unfortunately, maintenance. As soon as it becomes maintenance, it's got a limited life. Quite often, and it's like the molten sodium experiments.
Do you know much about that?
I know a bit. I know how it works, and
right.
And the one at Port Augusta sort of unfortunately just didn't get to the end, but that was probably a couple of technical challenges and maybe some financial challenges and things like that. It's medium-term storage, very high temperatures. There's challenges there. I'm not an expert in it,
I understand.
but certainly I've heard the bits that probably meant it couldn't go ahead.
There's also, the compressed air and the pros and cons of that, and remediating mine sites or converting them and using them as chambers. In China, they're actually building, crazily enough, digging up specifically for compressed air. So it must be economies of scale thing. Have you seen that gravity battery? The one that weird one. I don't know if anyone uses it, but it's weird looking.
It's the old tick 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 tick. Boom.
That's it. Yeah,
it's almost like a Monty Python catapult, isn't it?
I can appreciate.
But once again, if you get the mechanical reliability under control, it works, and that's where Flywheels is a balanced system.
Yeah,
there's clearly some advantages in that. And
I think some of the first projects first big project that will come to fruition will be probably a combination of the chemical battery with a flywheel, with the advantages of both. And hopefully, because I'm really passionate about it. I just love the idea that and they've been around, and then but again, the market will determine their uptake.
Yeah, it'll be that word hybrid.
Hybrid,
and what does that mean?
I know. It's funny. I always used to think hybrid. Well, in the early days, it meant wind and solar together on an off-grid system. And did you have much to do with any, personally, any large off-grid systems at any stage?
Not huge. What we called RAP systems or remote area power systems in the day. Yes. So and worked on a few. Not my main area. I think Jeff Stapleton, GSCS is certainly the pioneer in that area. But as a almost systems engineering, here's a system, there it is. We did a few back in the day. And technically what we were doing with the Iterranet stuff was effectively a RAPS. It was 6-8 panels on the roof and enormous amount of storage, 20-day storage capacity. Yeah, but that's exchange, exchange thinking.
You're not going to have a diesel generator in the middle of nowhere, are you?
Yeah.
That's the thing. Do you see, obviously the Pacific Islands around Australia, they follow the same 400-volt nominal. Do you see a lot more batteries going into those places? Solomon Islands, Fiji? Yeah.
The answer is yes.
I knew it would be. No, of course.
And
obvious, aren't I?
And a lot of those 4777.2 is the thing, unless it's the French. But then that's New Caledonia. Enphase, there's a lot of systems there because it's French, and it's just the French standard essentially.
So they don't have the same voltage. No, they do.
They have the same voltage, but their grid settings are because it's a overseas territory of France. There's the French still have like Tahiti is sort of special area, and Tahiti has 60 hertz, not 50 hertz, which makes there's a bit of a scattering. I did a study on the Caribbean a few years ago.
Yeah, right.
And it's every kind of different system you can think of. Being close to the US is clearly split phase. 60 hertz, 120 volts, so that's easy to deal with. But then you'd find in some countries it'd be split phase 50 hertz, or the Dutch would be delta 220 volt 127. There's every myriad of different systems.
When you're saying it reminds me of the old train tracks. In this state, this is this gauge. You go to the next state, it's this gauge, and it's quite weird. Have you looked at all at the African experience in regards to battery storage and where they're going with it?
Yes and no, not directly. Certainly been through accreditation for South Africa.
Wow.
And that tends to like NRS standards, which is an interesting mix of European. Their original standards were based on the first 4777. So pretty identifiable, but more recently, more on the German BDE ARN 4105 type standard. The interesting bit in their regulations is they've got a very hard and fast limit on the size of battery you can have compared to the service, which is something we don't have here, 25%. It's like that's how they protect their network. You can only
Okay, is that a good idea? Like for
For where they probably own rural areas, yeah.
right? Okay.
Yeah. But then and that's only very recent, last few years, that sort of requirements come through. If anything, it's an interesting market, but there's there's different grids there. There's the western grid, there's the eastern grid that runs up the side, there's the southern grid, which is sort of Africa, Namibia, and those areas up through the middle, up to the Congo. There's a lot of money going in there, but it's still what I'd call network level project.
Right,
and that's typical of any country that sort of adopts solar. It usually is network, and then it finds its way once there's net metering that they end up being on the roof type stuff. But
gosh, we really are quite ahead. I mean, I'm just fully realising how far we are ahead in Australia with all of this stuff after talking to you. I just didn't fully realise. Very interesting. I got to say, when you've got time, love you to come back for a part 2.
Yeah, no problem with that. Yeah.
There's a lot I didn't even really look at the brief.
There's a lot we've discussed without getting off the main subject.
We have, but there's so much more. I mean, you're very understated about your accomplishments and what you've done. I can tell, but it's been wonderful. It's been really good. So thanks very much for coming in. And it was an absolute pleasure.
Thank you for the opportunity. Look forward to part 2.
Absolutely.
Thank you.